Idyllic islands and bustling cities such as Venice and Miami may be spared from rising sea levels in the near future because parched land is absorbing some of the water released by melting glaciers. The planet's continents have soaked up and stored 3.2 trillion tons of water in soils, lakes, and underground aquifers, according to NASA. The agency analyzed satellite measurements collected over the past decade to show the rate of sea level rise has slowed by 22%, although the effect may be temporary. We always assumed that people's increased reliance on groundwater for irrigation and consumption was resulting in a net transfer of water from the land to the ocean, said lead author J.T. Rager of NASA's Jet Propulsion Laboratory in Pasadena, California. What we didn't realize until now is that over the past decade, changes in the global water cycle more than offset the losses that occurred from groundwater pumping, causing the land to act like a sponge, at least temporarily. The global water cycle involves the evaporation of water droplets over the oceans to rainfall, which runs off into rivers that lead back into the ocean. The effect land storage of water has had on sea level rise has remained unknown until now because there are no land-based instruments that can measure such changes planet-wide. The latest data came from a pair of NASA's satellites launched in 2002, known as the Gravity Recovery and Climate Experiment, GRACE. Between 2002 and 2014, it measured changes in gravity and therefore underlying changes in water storage. The team of researchers, from NASA's Jet Propulsion Laboratory, the University of California, Irvine, University of Bonn, Germany, and National Taiwan University, combined the satellite data with estimates of mass loss of glaciers to calculate the impact land water storage might have had on sea level change. Their analysis suggests that during this time frame, climate variability resulted in an increase of approximately 3.2 trillion tons of water being stored inland. The team learned that the water gains over land were spread globally, but taken together they equal the volume of Lake Huron, the world's seventh largest lake. This gain partially offset water losses from ice sheets, glaciers, and groundwater pumping, slowing the rate of sea level rise by between 0.7 and 0.2 millimeters each year. They believe the findings, published in the journal Science, will help scientists better calculate sea level changes in the years ahead. These results will lead to a refinement of global sea level budgets, such as those presented in the Intergovernmental Panel on Climate Change, IPCC, reports, which acknowledge the importance of climate-driven changes in hydrology, but have been unable to include any reliable estimate of their contribution to sea level changes, said senior author J. Famiglietti, a professor at the University of California, Irvine. But we'll need a much longer data record to fully understand the underlying cause of the patterns and whether they will persist.